What's up, everyone? It's me, Shoumik, and welcome back to my channel. Today, I'm going to talk about my latest image process project, which is based on ResNet-50 for Flower image training. So you guys might ask, what is ResNet-50? So basically, ResNet stands for Residual Network, and it was developed by Microsoft Research back in 2015. That was 10 years ago, nearly. And it's one of the most influential convolutional neural networks for complex image processing and so on. So ResNet actually is a pre-trained model, and it comes with ImageNet, a pre-trained source. So what is ImageNet, you might ask? So ImageNet is the project which is like the instrumental in developing computer vision and deep learning research, and the data is available for free to researchers and non-commercial users and free learners like me. Okay, so. Um, to begin with, where I've actually found the dataset, you might wonder. So I use the dataset from Oxford Academy database. Here it is. So 102 category flower dataset, as you can see. And so in the download section, what I've downloaded is like the data images, which I'll be needing, and the image labels and the data splits. Image labels are are the file for which I can specifically determine that which flower is what in the image. So that would be the classification, and it will help my codes and programs to do so, to identify. And the data split that you're seeing here, it is for test evaluation. Sorry, uh, yeah, train, evaluation, and test. So these three parameters will help me to determine the flowers more accurately through the images and through the identification. That's all. So now let's jump into my project. So as you can see, as usual, I have called upon the necessary libraries which I will be needing through my project, and also I have mapped the 102 flowers by the names that you can see here, like the pink primrose and primrose, and also the hard leaf pocket orchid or whatever, like 102 names. So I'm not gonna call all of those in the video. So sorry. Moving forward, what I have done now is combined all the datas. So, where are my datas actually? Well, my data is right here. As you can see, what I have stored is I have downloaded them, mind you, and then the here and here and finally here. So as you can see, there's a JPG file, as I have showed you in the website. The where's the website? Oh yeah, yeah, the data images that you can see here, and it's like the JPG here, and the image labels that will be it will help to identify that which flower image stands for what in in Word, and also the set ID, which will also help me to determine the training, evaluation, and also the test process for bringing the flower identification more accurately. So in the data set, I have like 8,189 images, and those images belongs to 102 types of flowers, as you can see here. So I won't go through all of these images, but I can show you ultimately there are, look, 8,189 images. So that's a lot of images that I have to train right now. And to do that, I have combined all these datas at once through my code in the block, as you can see. So here, what I've done in this section is handle the dataset preparation using the Flower 102 dataset from torchvision datasets. So, which means that Oxford Library dataset. So the dataset is split into the training and validation subsets, thanks to the the small files that I have downloaded with the prerequisite, and also a transformation pipeline is applied to resize these images to the standard input size. for ResNet-50 and the resolution 200 to 24 into 224. And now you might ask, why 224 into 224 resolution? Because it's the standard resolution that the ResNet-50's convolutional neural network will obtain, and it will make much more sense to the neural network, and it will be more efficient for the neural network to do so. So for computational accuracy and efficiency. That's the case. So it's all based on ImageNet statistics, which I have showed you the website. And this is a free source website, by the way, and it has like 1 million, over 1 million images. And you can, through this website, it has been trained and labeled through all, like all of the data sets that you see or you can get to train in the convolutional neural network. So moving on, so I have loaded all the data which was necessary. Like here, I have like directed my data path. Like I have marked, I'm marking here as well. So the E drive flowers and flower 102. Like let me show you. Like here, see here, like my E drive, like the flowers folder, then flower 102 file. So from this file, I have like combined all those data, like 8,189 flower image data all at once, and then I have like made them ready to get trained. So that's the case here. And then I have freezed all the ResNet-50 layers except the classifier. Now, you may ask that what's the meaning of freezing? Like, let me tell you. Conventionally or normally, ResNet-50s, like the normal layers, take the prime or the normal specifications of the pictures, such as pictures like pixel length, color, normal like shapes and so on. So uh, by like just imagine like for each of those pictures, if you take all those like tribes like individually, it will take a lot of time and a lot of computational power. And to decrease that and to save up my time, I've freezed the layer. Actually freeze the layer, like the meaning of freezing the layer is actually like I have like minimized the the processing, which is like taking all the tribes of the images for individually. I have like limited the process, which means that I have like like meaningfully or selectively pre-trained my model through 1,000 or 2,000 images, which will be resembled into all the images in those to 8,189 images. And by that, I have got the overall idea or the overall like the data types that I'm going to need to train my overall model to recognize the images of the flower with the names as well. So this is the meaning of freezing, which means that I will take a like specific population of the images, and I'll like train with those images with my model at the beginning, and then I'm going to take the overall idea of what I'm actually working on and what I'm going to achieve. So that's the thing actually here, what I'm doing. So here, the pre-trained ResNet-50 is initialized for transferring learning, and all layers are frozen to retain the pre-learned, like weights for ImageNet, and except for the final fully connected layers. This final layers is modified to output the prediction across like 102 flower classes, aligning with the model with the flower 102 classification class. So this technique allows the model to adapt to the new task while leveraging the learned feature representation. So moving on, what I'm now doing is determining the loss and optimizer. Now you might ask, what kind of optimizer I'm using here? So the optimizer that I'm using here among all the optimizers out there is Atom. ADAM stands for the adaptive moment estimation. So why specifically I have used ADAM? Like I could use many other optimizers, right? So I've stumbled upon a paper recently, and what I have learned from this paper, like as you can see, let me just zoom it, that over the past decade, from like 2010 and 2020, you can see that the number of optimizers has been increased for deep learning, and the optimizers that have been like used over the decades is shown here in the legends with the colors that has been used. Like for Atom, it has been used red, and for SGD, which has been used much more, is like dark blue or something, and others is other colors. So my point is about Atom, right? So if I see correctly, through the years, the usage of Atom has been rising has been increased. So why Atom has been used so much as an optimizer in deep learning? Because Atom is computationally efficient and more reliable, and it can bring the outputs more effectively and in an optimized way. So that is why Atom is used much more, and it is using till now to the date for many types of machine learning research. If you like, search about it. So okay, so moving on, I have trained in a loop my all the data sets here, and I've also used tqdm for visualization. That how much progress did with the I did with the images that I have trained all through the process here, as you can see. So first, I have like got my data sets ready, which was like 8,189 images. Like I have made them ready for the loop and for the process, and then I have ran the training in 5 epochs. So it actually took me a lot of time to run these images all over again. So um, it took me a lot of time, like, like estimated 4 hours or something, because my laptop has no GPU, first of all. And what I'm doing is I'm training the model with only CPU. So that is why. If I had GPU, integrated GPU in my laptop, then it would take like, 1 or 2 hours or something, or it might took less based on the graphics card power or model. But it took me like nearly 4 or 5 hours. But uh, I've trained all of the images, as you can see, and I have also like achieved the perfect, near perfect accuracy, which is 96.26 percentile. So I think it's like a good thing actually. So moving on, so evaluating my test set, what I have done here is to like like since I have tested my data sets right now, right here, just now. Then I thought that maybe I should like get some idea about the test results or test loss or test accuracy. So I have done it here, which will also like enhance my accuracy and also the capacity of the identification of my model. So that's it. And then nothing. It's not much, but I think it's worth it. So moving on, I have I have made a self test of my model here. So what is a self test? Self test means that since I have trained my model with all of those images just now with 5 epochs approximately, so I thought that why not test my model right now to see that if my model can predict the images of the flower correctly or not. So what I've done here that I took a test drive. So what is so what is test drive? Like if you like buy a like new car, you obviously want to like test it out to take it on a test drive to see if your car is like moves well or not. So that's the thing. What I've done in this model, like in this like code block, is I have like tested out my data and my models to see that if it actually like accurately identifies the flower image with the perfect name or not. So In the result, as you can see, that the actual label it has predicted is percent started. Oh my god, 25%. Okay, so how the label that is selected for now is 35. So what is label 35 means? The label 35 flower, it means that like the ruby-lipped cattleya. Okay, that's flower name, and then uh, what is actually it has predicted label 20. So as you can see that it didn't like accurately predicted the flower as it was meant to be. If it was accurate, then the predicted label would be 35 as it is in the actual label, but it hasn't. So what is 20? The label 20 indicates where it is. Like yeah, fire lily. So that's really incorrect. My bad. But don't worry, I have fixed it later on. So moving on, as I have layers. Oh, the flower picture it has shown just now, which it has like it had predicted. So as it is like not like what should I say, like not has predicted the flower image like accurately. So I thought that maybe I should do some more work in this, even though the accuracy is quite good, but it can sometimes happen that it can like predict falsely at the first run, but later it will be good. It will like predict accurately. So now I have trained and validated the ResNet-50 again, since it has like for making the cross check that it wouldn't happen again. Like it wouldn't happen again means it wouldn't like predict wrongly again. So that's it. So that's the case. That now what I have did that I have trained again with 5 epochs, and uh, just now what I did is the time took very less because the version of epochs that I have trained here is like much more like simplified. But through this simplification, I have like increased the overall accuracy of my model to like uh, uh, like accurately judging the image and then like processing the name and then giving the right output. So as you can see, the training loss and the validation losses are decreasing, like substantially through the iterations or through the epochs. Like it was like 4.5314 at first, like epoch one, and the validation loss was 3.4 something. Then it went like low, 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 and low. So I have also created a visualization like later to like make it much more like visually comprehensible like what actually has happened. So as you can see here, I have made a graph like a progress graph for training loss and validation loss. So as you can see, like at the first, if I talk about training loss, you will see that what it was the loss was like 4 point like 5.6 or something at first. Let me see. Like yeah, like 4.5314, like slightly maximized. So yeah, so 4.53. Yeah, it is slightly upward from the 4.5 as you can see, and then it's like slightly 2. I think it's 2.7 or 2.6 something. Let me check. Okay, so in the epoch 2, it's 2.59. Oh, so to 2.6, nearly 2.6. So yeah, so it's like like in the here it's 2.6, then it decreases again, again, again. So substantially, you can see the curve or the graph has been decreased, like substantially. And the same thing has also happened in the validation loss, as you can see. So the validation loss has been also decreased over the epochs, like here. Like as you can see, the validation loss was like 3.44, then 2.29, then 1.695, then so on. It actually decreased. And if I tried on like epoch 8, epoch 9, you could see that it could like run down to 0.9, 0.8, 0.7, and so on. So I just wanted to like try it out on 5 epochs because it's a huge data set, it's a complex data set. So uh, less epochs, uh, a good result. If you have a high-end laptop, then you can run on 10 epochs, 20 epochs, possibly 100 epochs. But since I have a like no GPU laptop, that's why I've run it on like only 5 epochs. So never mind. Okay, so and also there are the validation accuracy. Like the with the epoch, the accuracy has increased substantially, like you can see in this graph. So where's the accuracy? Like look, the validation accuracy. So let's see what's actually here. 34.12%, then 61.57%, 74, 75, 80. So yeah, the validation accuracy increased, which is good news because my model can overall can more accurately predict the results. Result means the accurate flower name with the flower image. So that's the good thing actually. Now, finally, I'm going to visualize or I'm going to like make a test of the prediction of flower again. So here I have through my code I have called out random flower to like check if I can through the six trials, how many through the six trials, how many of them are accurate and how many of them not. And as you can see here, the first picture is pink primrose, which is true, but my prediction went actually wrong. And what is this? Like balloon flower? It's not balloon flower. It's primrose, but this one trial went wrong, but my other five trial went very right because my accuracy slightly increased to 96% before to 97% through all these all this validation and again the epochs that I've run. So my accuracy like really increased over the time, as you can see in the graph. So yeah, so the five of the trials went very good. Now let's see if it actually telling the truth or not. Like if my model is telling the truth or not. So I'm going to snip the picture. Yeah, snip. Yeah. Okay. So okay, let's go this one. Okay. Okay. So copy and okay. Yeah. Oh no 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 no. Sorry. Not to Google it. Google, Google, Google. Okay. Google. So lens. I'm just gonna paste the picture here. Okay. So okay. What? Okay. What is the name of this flower? Okay. Come on, come on, come on. Yeah. Uh, evening primrose. You see? The model told me the correct, or given the correct prediction as I've expected. So it's a primrose. Pink primrose or evening primrose, whatever. It's pink. Like look at the image. Like yeah. Yeah, it's pink. Yeah, my cursor. You see? So yeah. So far my model is good enough. So thank you for watching, and I'm gonna come up with more machine learning, image processing videos. Later on, most probably, most of them will be on industrial engineering, since my background is industrial engineering as well. So yeah, thanks guys. Good luck. Ciao.